My name is Sergiy Nesterko. I'm really happy to be here today. Thank you organizers for inviting. It's been a wonderful event. Really excited to be here, all the way from Toronto. Також я українець, дуже приємно повернутися на Україну. Черкаси, хтось з Черкас? Ніхто. Так. Черкаси, So I'm going to be presenting in English. It's much more easy for me to do it this way. So here's me. I'm a manager at Omnia AI. This is a recently opened Deloitte Canada's AI practice. And I focus on solution delivery and development across sectors of the economy. And my particular emphasis is retail, specifically grocery retail, and also financial services, specifically insurance, but also banking. And it was really wonderful to listen to other talks earlier today, focused a lot on different aspects of AI and data science. And this is something we think a lot in our practice day to day. What we focus on is large-scale project delivery in the economy. And the focus of my talk today was to share some of the stories from the field or from the actual large-scale projects and some of the strategies we use day to day in tackling some of the challenges and tools we pick and the constraint we face and my teams face every day. So some of the takeaways from this talk, I hope to convey some of the spirit of outcomes. We're really forced to deliver outcomes more and more as data scientists within the time constraints that we have in the projects, and also some of the philosophy and mindset that we try to teach our clients, also trying and looking to represent a certain school of thought when it comes to actual large-scale project delivery in the economy. So I hope it's going to come across a little bit more during my talk. So before I begin, I wanted to introduce Deloitte, my employer, who allowed me to present here today. This is specifically Deloitte Canada, but I also met my wonderful colleagues from Deloitte Ukraine earlier today, digital lab studio. And in case anybody is looking for a job, please email those guys. Guys, can you raise a hand? Yeah. So that's the key of office, please do. But more globally, the firm is really well known. It is large scale, and it has 30 interactive facilities around the world, including Singapore, San Francisco, San Diego, Toronto, New York, all around the world. And by interactive facilities, really these are rooms where people come in, and by people we mean clients, executives, or say data scientists. And it's an immersive experience where we look for solutions together with our clients and co-develop solutions together with the clients. Digital design studios. So these are the studios that develop apps, develop interactive experiences all around the world. Also, Deloitte network is represented across 150 plus countries. A lot of professionals all around the world. So really, the reach of the firm is really big. We serve virtually, I would think it would be safe to say, every large company in the world. So what about Omnia AI? This is the place I work. This is the Deloitte Canada's AI practice. It has 337 practitioners, and roughly the breakdown is listed on the screen here. Around how many data scientists here? Yeah, over 60 data scientists, strategy professionals, information design, so people who, we actually employ professional designers. They don't do anything else but draw. Multidisciplinary, and then data architecture. So the approach here is to have a holistic team that can really tackle a project end-to-end, a large-scale project end-to-end. Okay, so this is just where I'm from. So now all of that aside, and that's my challenge as an academic. Some people would say recovering academic, but I actually want to bring science back into my work. I really miss science or science-led approaches. However, my personal struggle throughout my career at Deloitte, which is 4.5 years at this point, has been that I have to keep pace with our field, which is rapidly evolving, while being able to complete those projects. There is very strict expectations when it comes to budgeting, timelines, context, interpretability, you name it. In different industries, they're always different. But to me, the personal struggle has been like, I want to keep the research component of my work going while being connected to the massive clients, which give me an opportunity to have impact from our work. And so the only answer I give myself, like I struggle all the time, I just need to keep on it, I need to keep trying. So, and that's also what I try to say, that we have to keep trying to understand all the new methods. That's why I was so excited about the different tools and techniques that the speakers were sharing earlier today. I'm hoping to share some of the practical approaches that our teams employ today. So there's kind of 4 themes more philosophically that we think about day to day in our work. So concept, tools, implementation, and mindset. Kind of this is pretty abstract. However, what we try to do as well, and what has been kind of tricky for me as a data scientist, to be very clear about what we're doing and what we're not doing. And so it always helps to communicate and bucket things. So let me just explain. I was trying to frame how we think in our project delivery, what mindset or how do we approach our work day to day. And how do we describe it to our large-scale clients so they understand us too. So what we believe in our projects is we have to try and maintain scientific approaches. And this is actually a big challenge in our work, to keep using research-grade work and also treat every project we do, a successful project, as something we can publish. Something we can publish in an academic paper. We don't always publish, but we really try to publish. And this has been the holy grail for me personally, because when you pay 7 to 8 digits for a project, you want to try to contribute something back, not make it a one and done and this is it, just ship the project, make the money and forget about this. So my personal best outcome is just recently, a month ago, our client, a governmental entity, they said, hey, wouldn't it be cool to publish this? I was like, yes, I like this. And Deloitte actually publishes together with our clients sometimes, which is a fantastic outcome. Doesn't happen always, but this is a fabulous outcome. Now, tools, obviously there has been constant advance in how the technology is developing. New tools are heavily advertised, marketed. Some of them are free, some of them are not free. You have to figure all of that out. And partnerships, they do make sense a lot of the time. However, in each case, we've got to understand what the client context is, what makes sense, what doesn't make sense. Do we want to develop our own pipeline? Do we want to use something else? When does the partnership make sense for our client and for everyone involved? And generally, in the market, we're seeing that open source is quote-unquote an emergent standard. And what I mean by that is open source, truly open source tools, freely available tools, they have become more and more available. So can I get a show of hands who uses truly open source tools, like non-paid tools, like GitHub, right? Makes sense. So that's what I like. I'm with you guys. We want to try to get our clients to use that, but there is a challenge. Not always that happens. And there's different circumstances that lock clients into the tools that they have to keep paying for. And sometimes it's good, sometimes it's great, but there's pros and cons to it. So it's something that we have to be comfortable about and understand how it works. Now, implementation, this is probably my biggest challenge, personally, because there's very strict economic expectations. What I mean by that, there's always a timeline, there's always a budget, and you have to ship your product within the budget, right? But how do you stay innovative? And there is an inherent kind of lure to try and use a tool that just works. You plug something in and gives you an output in the format that you need, kind of a model, it kind of works. You don't always know how it works, but it just works easily, boom, done, all right? You've done it within the timeline. You've done it on budget, even under budget, fabulous. But how do you keep trying to instill in our clients, educate them, that you have to try and stay innovative? So my personal aspiration is to look for that innovative spirit in every client of mine. So every executive, so my personal story from as of recently, so we've recently signed up a big project with the chief information officer of a very large grocery retailer, and he's a dreamer at heart. He's a dreamer. He wants to innovate. He wants to do new things. He wants to keep pushing the boundaries, and that's what we're here for. We're trying to help them do that. And finally, the mindset. When everything is tough, it's like the mantra. Okay, I go back to the mindset. I have to maintain the mindset, focus on my concepts, choose the right tools, implement correctly. And you know what? I can start from anywhere. Every model is a good starting point, but you know what? You have to iterate and improve your models. And a disciplined focus, make constant discipline focused on the quality of prediction, and just keep repeating that to myself and my clients. Hey guys, we have to be focused on improving our models all the time, and this is where the iteration comes in. You have to keep iterating and doing it all over again. So this is kind of what we think about. And today I wanted to describe just two projects, two stories from the field to you guys in terms of us, and I will touch a little bit on the technical as well. Hopefully we'll learn something together. So this particular project was for a governmental entity looking to analyze image data and video data for the presence of various unwanted objects, let's say. So things like public safety, safety of postal mail, packaging, and so forth, our great industry, government. Something I learned personally on this project is a lot of this surveillance currently in the world is done by officers, by physical people. There's very little machine assistance, which is interesting, right? A big country actually receives on the order of hundreds of thousands of packages every week, by different ports of entry. And all countries of the world currently, they never actually utilize image recognition or AI for this, right? Isn't this strange, right? And so we want to bring that research to the government. And this was for one of the agencies. The challenge, however, that the agency faced in this was very specific. Well, they knew that AI research exists and that it works really well from research, but how do you actually make it happen? And when you start thinking these things through, things become much more nuanced. Because, okay, you're a government, just think about it. Like you're a government of a country. How do you make AI happen? What do you do? Okay, I need a good infrastructure. I need to deploy these models. But then, okay, I don't have any data scientists, or my data scientists are not as comfortable with the tools. And also, I have various sources where that imagery is generated. So it sounds like a massive project, right? Just think about it. You're a large country, and you have things arriving to you every day, hundreds of thousands of images getting generated, video feeds from different ports of entry. Where do I start? How do I do it? And this is when they partnered with us and with a large technology provider so that we create a prototype solution for them that's going to show how all of this is going to work. At the same time, they were really interested in putting it in the context of what other nations are doing, right? If you're a country, you don't want to look too bad compared to other countries or other initiatives or other. So all of that played in the equation. And so the approach that our team took is partner with a leading cloud provider so that we have our infrastructure checked off. But also we wanted to help our client to develop a cloud agnostic pipeline so that there's a little bit more freedom for our client to maybe switch providers or have an in-house, on-premise infrastructure. You guys are familiar. It's just I'm using our professional speak. On-premise versus cloud infrastructure. People are familiar. Can I get a show of hands? On-premise versus cloud. On-premise versus cloud. Yeah. So on-premise, this is when you kind of have your own set of computers. Your organization maintains their own IT and say your own Hadoop cluster or whatever it is. And then in the cloud, that's on-demand deployable solutions. And say me personally, I'm a huge fan. So in the research, we had like 10,000 node research computer, like we called it a supercomputer. And this was amazing. You just load your queue up. You have 5,000 nodes working on demand for you. But what happens when you move into the actual real life? Those things are not cheap, right? So any guesses how much a year of a stood up on-demand cluster could cost to a large company? Can I get just a shout out?
10 million.
What?
10 million.
Okay. 500K? What's that? 500 million. Okay. Okay, yeah, so Alex knows his work. That's kind of around the right guess, right? And so that's a lot, right? And so you don't want to just like do it right away, you know? Because I think, you know, if I can save my client half of that, if I put it in my back pocket, I retire, I'm done, right? If it worked that way. Unfortunately, it doesn't. And clients, they're not silly, they understand. They don't want to overpay. They want to pay for the right amount of data, for the right infrastructure, and for the right product. So this was the challenge, and our approach was to develop a pipeline for them and run it on a sample of imagery. And so now I wanted to delve a little bit deeper in the technical considerations of this project, even though, frankly, I do believe it's much more, the first thing that I was saying is actually a bit more important, at least right now, for most of our clients. And I just wanted to emphasize, most of our clients are actually outside of technology. It's actually basically all sectors outside of the big tech players that we work with. So a little bit on the technical side here. So what we learned during this project is that, this is actually my second computer vision project, is that computer vision models are trainable on limited numbers of imagery. However, they tend to overfit in the sense that they learn objects, say, you know, you can show it, you can try to classify a mammal, and if you show a lot of dogs to them, and when you show a camel, you know, a camel, it's not, it may or may not, it's going to have a high error rate classifying a camel as a mammal. You know, a mammal? Mammal is like, you know, right? So that's what we learned, and this was a tough, kind of unexpected experience for us. And it might sound simple to a lot of you guys, but just think this through. We have military people in the room with us, and we're hacking together with them. Military client side, and you know, the actual, we hacked together out on the West Coast with our cloud partner and with the military people, and we figure out, oh wow, we're overfitting to the objects that we're having. This is like a big deal. And so our team almost felt a little bit like a DevOps team because we pre-prepared. People familiar with DevOps? So you know, what you do is you create your pipeline ahead of time, and then you try to deploy it against the imagery that, you know, that you get, right? But then the DevOps, this is when I figured out that DevOps is a really important job, because you have to troubleshoot in real time, really fast, find solutions really fast. And we didn't have a single software engineer, we had data scientists, and our cloud provider didn't help us much, so we had to troubleshoot in real time. So let me just go over a slide a little bit. So in our proof of concept, we needed to detect 24, well, we were working with 24 objects. Oh yeah, and by the way, surprise, surprise, right before finishing the project, right before kind of making the final push on the project, we figured out that our client was unable to provide real imagery to us. They were able to provide it for test. You know, people familiar with train, test, validate splits, right? Most people are. So just for people who are not as familiar, you know, you train your model on a certain set of data, kind of you show certain set of imagery to your model so that it learns how to detect things on images. Then you use a validation split to kind of provide feedback back into training. And validation is kind of like your training plus model kind of set of data. It kind of helps see how well your model is doing on a set of data that it kind of is starting to become familiar with, but not as much as training. And I'm being a bit vague about it, not too technical. I can go pretty technical too if you guys want. So if you guys want to ask questions afterwards, easy. And then test set, this is the set that you really don't want to show to your model a lot. You only use it kind of a very limited number of times. How many people use their test set more than once? Ever? Okay, I see a couple. I've done it, but it's a sin. You don't do it. You're not supposed to do it. Because it's kind of a philosophical concept. You don't want to use your data twice. Anybody knows use the data twice? You don't want to use the data twice. Because then your model has a risk of becoming more overfit than expected. And you know, it kind of creates a risk of creating a non-robust model. But that's, again, a bit of a technical concept. So basically, we had 24 objects, and so we didn't have real data to train our model. So we had to create fake data. And what we learned that actually making fake data and training your model on fake data actually works. Works okay. And so what we did, we had 24 objects. We created over 1,000 variations And then the second line, the 3D models open source, actually another big learning that we do all the time is we try to bring in external data. How many people have brought in external data into their projects? How many people do commercial projects here? Good. So that's great. How many people have brought in external data set in addition to their client data set into the mix when doing it? Fabulous. So for those who don't, I really encourage you to do that because the value add to your projects can be massive. So what we did here, we actually looked up on the internet, actually like on gaming websites and so forth, modeled objects, and we brought them as well. And then we created what we call synthetic imagery. Oh, I don't have a lot of time. Synthetic imagery by overlaying data. And then we looked to create several sets of data. Original, without the internet imagery, original plus 3D, and then training, test, and then a few test sets to test our performance. And remember, what's at stake here is a large government-wide implementation project, massive. And this is us just hacking away, okay? So another learning that we try to abide to is obviously we want to compare models with metrics that are domain specific and are referenceable in research papers around it. So IOU is intersection over union method for looking at false positives and things like that. Precision recall in image recognition. So that's something we also try to instill in our teams. Look, guys. Don't use generic metrics. Sometimes it makes sense to use domain-specific, like IOU doesn't exist in non-computer vision projects, right? People know IOU, right? Okay, so I know it's new to a lot of people, but basically IOU is, prediction, the model makes a prediction that's a green, so we're looking for a cat, we're looking to detect an object in our image. So this is an example, we weren't looking for cats. And the model says the prediction is that the ground truth, called the bounding box, is red. Intersection over union is basically looking at where the rectangles overlap, right? And they divide the intersection by the union. And obviously, if they don't intersect, that's not good. The model wasn't able to place the rectangle right? That's pretty simple. So the only message of this slide is, in real time, during your project, it's kind of like a mini research project. You have to kind of figure everything out, put everything together, and use the right metrics. So let's see. So this is just a sample of our approaches. Something that I didn't quite hear from other speakers, but something that I find extremely useful in our work, extremely useful. Always implement multiple models. Always implement multiple models, but always the clients are looking for you to go an extra, walk an extra mile and take that extra step to actually show to them that you have a sufficient understanding of the trade-offs between the models. It shouldn't be a blind choice. So we implement multiple models, SSD, RetinaNet, and YOLO. And in this particular project, guess what happened? We weren't able to execute all of our models on all the sets. We were time-boxed. And so this is the performance we got. Precision recall. How many people know precision recall term? Precision recall, pretty standard. Okay, so precision, this is basically, just for those of you guys who didn't raise your hand, precision, this is the number of true positives out of the labeled positives. Recall is the number of positives out of total positives that you flagged with your model. So this is kind of, in this particular instance, the client was really cared about recall. They didn't care about false positives that much because they wanted to catch all the bad stuff. And then they double check all of your false positives. It's okay because the risk of not detecting the bad stuff is so high that they would rather catch the bad stuff. So, and here's the surprise. So there is a research paper that another large government published about image detection. What they did actually was a fundamental flaw when we actually read that research paper, and that's what also I think is another kind of piece of learning. Not all research papers have sound methodology or fully sound methodology. What they did, they also used synthetic imagery, but they never had net new objects in their holdout sample. So they had the same objects in their train and validate as in their test set, just a different rotation. So you could say it's a different image, right? But the object is the same, and that's where we learned the hard way. these numbers show us, they're lower, that models are not very robust. Okay. So secondly, what we do is we try to compare our results. So this is our literature search, and we place the current performance of models. And yes, we know that frames per second are highly dependent on hardware, and we weren't able to recreate the same hardware setup as the research papers. But this plot is showing accuracy. So I'm not going to explain mean average precision right now, versus frames per second at what they call inference time. It's a slang where basically when you predict, when you process per image, frame is an image, like a video. So, and you kind of place those boxes, try to detect images. How many images can you process per second? Frames per second. And obviously, the higher frames per second and the higher mean average precision, the better. What we see is there is a trade-off, right? Performance versus speed. And I haven't placed our models on the plot here, but what we did in the final deliverable, we actually showed them, okay, hey, look, here's what the research results are like, and list of references of research papers, and hey, here's how our models did, and here's where they are on the plot. And like, wow, let's publish this right now, right? So this is, and it sounds pretty trivial, except for this is a real government. This is not an experiment. This is like military colonels in the room with us. So this is what psychs me up. I'm like a data scientist, a very technical person, but I'm really excited to be exposed to these kind of really high-flying projects. Isn't this exciting? This is what we are here for. We're here to do real stuff, right? At least I was. Like I downgraded from pure math. How many people know that if you move from pure math into applied math, it's a downgrade? I see people smile. So it's crossing to the dark side. And then when you move from the applied math into consulting, I don't even know what that is. It's like you sell your soul. Okay. So guilty as charged. This is all I had for this project. Again, this is just to expose to some of the stories. And obviously, just to recap, this is a story of a real project where we elected to partner with a very large cloud provider, like a very big one. But then we opted to tell our client and recommend to them to say, hey guys, let's not use just the turnkey image recognition pipeline of the partner, just because, hey, guess what? Maybe you want to have your own infrastructure someday, right? Maybe you don't want to, keep being locked in, right? So that flexibility was really important to our client, and that's why they decided to go with our services. Okay. So this is another project. So this is one of my personal favorites. This is for the actually auto industry, a car maker, a global car maker. So what happens in automotive is whenever you get a car, and I'm sure also here in Ukraine it's similar to that. Like get a car, get 1,000 hryvnias back, or like cash back. Is cash back a thing here? No? Yeah? So it's the same everywhere. So what I learned myself was very interesting. That cashback is budgeted and paid for centrally normally. So if your car is, say, German, the cashback actually comes from Germany, like direct. Well, I mean, it's budgeted and transferred onto the local, say BMW Ukraine account, but the budget is set globally. So the manufacturer was wondering, how can we optimize our what they call marketing expenditure on our vehicles to boost demand, but also not overspend on our things like cashback and TV advertisement and so forth, by country, worldwide. So that was interesting. And this was interesting because this is another challenge that we face. There is a very strong incumbency in that area where, how many people are familiar with marketing mix models? Marketing mix models? Okay. So marketing mix models, it's basically a linear regression that relates your units sold as your Y variable to things like cash you spend on each unit, amount of airtime you get on TV as your X variables. Very simple. Once you fit that model, you can have a constraint optimization, like a linear program, linear program, constraint linear optimization. And technical people in the room, hey, that's right. That's the marketing mix model. And we thought, hey, it's such a strong, by incumbency means it's adopted in industry, like it's widely used. Everybody uses it, everybody. And our team was like so annoyed, like this is so old. We don't want to use this anymore, let's use something else. And we're like, okay, let's do this, let's do something else. So we decided this is gonna be our differentiating factor, and this is how we try to talk to our clients, is we want to differentiate ourselves by doing something new, something interesting, something comparatively more performing, something forward-looking. So we built actually a heuristic optimization algorithm using a deep learning method, which I'll describe now, as the backbone, so, which was published 2 years ago, which my personal highlight. I like using recent research, and I'm going to describe how that happened here. But before we go, so just some plots to show performance. This is what we would show. So cash incentive PU, it means cash incentive per unit. I only have 2 minutes left, not a lot of time, so I'm going to have to speed forward some of this. The actuals are the dashed line. This is the actual per unit spend in one country. Optimal, this is what our heuristic algorithm said should have been the optimal spend. And the range is, we provide kind of the range how it could have been. So this is our forward-looking prediction that we churned out. Now, it's very important to understand how every output is used by the actual organization, right? The way this is actually used is, okay, it spits out a chart, and the guys in finance, every January, they sit down, and they're like, okay, so we have like 100 million. Are we going to give this much to like Germany, this much to like Russia? Like, let's look at this, right? Let's like move money around and kind of make it happen. Simple, right? Well, you have to make it digestible, make it understandable. So this is pretty understandable. At least to me, this is like dollars, $500. So per vehicle, $1,500. And you see how, car sales, they actually spike up, in the summer, coming up to Christmas. Coming up to Christmas, and right around Christmas there is a dip, and then there's a dead zone in the end of winter, which is February over here, and you got to climb up. But details matter, especially things multiply. Obviously, my personal favorite, the reason why I'm focused on grocery retail and financial services, specifically retail, banking, and insurance, is because we like large numbers. We like a lot of units. Statistics work law of large numbers when there's a lot of repetition, so that when your model is right a little bit more than half the time, that's where you bring value, right? When you improve your grocery sales from 70 billion by 1%, 1% of 70 billion is a lot of money, which is great. That's when you can start doing performance-based billing and so forth and budgeting, which is fabulous. So a little bit of a technicality. This particular slide is something that gets me really excited about adversarial learning. How many people learned about adversarial learning? Adversarial learning is to me, this is the highlight of the recent deep learning development. And basically what it does, the way this works, and I'm at 0 time, is it learns by, this is a deep adversarial autoencoder. So it encodes, creates an embedding in a lower dimensional space of, say, your symbol over there, that's an X, and then it generates a fake one, and then it punishes itself for wrongly disambiguating the two. And I do have very limited time to explain this, but this essentially, in my opinion, perturbs the distance metric in the encoded space, which is a fabulous automatic goodie that you get, because normally when your models are underperforming, what you do as a data scientist, you change your distance metric and everything works. So, and what I like about it is it has an open source implementation. On GitHub, there's many more flavors at this time of adversarial autoencoder. And so I've got to close now. I did say in my synopsis we have fun along the way. This is our team. Can't you see how much fun they have? Right? They're eating their cookies for breakfast. Okay, so this is all I had. And what I wanted to say is themes change. To me as a statistician, I'm a trained statistician, themes change. There's new things coming up all the time, but we as data scientists, we must keep track with the field. We must evolve and stay on time, be outcome driven, be outcome-oriented, be scientific, and then the market is really big. So thank you very much. And I've got appendix.